The Airacuda was the first military airplane produced by the Bell Airacuda Corporation. It was built in the 1930s as a pre-war design that attempted to fulfill a U.S. Army Air Corps requirement for a new twin-engine multi-purpose platform. They wanted the plane to work well as a fighter, bomber, and reconnaissance plane. The reason for designing the multi-purpose aircraft was simple. It would be cheaper if one plane could perform all military aviation functions. As such, the Bell Airacuda introduced several advanced innovations for its time, such as forward-facing gun turrets placed on the front of the aircraft. The placement could tear apart any fighter formations that dared to take the fight frontally. One cabin with a gun was placed on each wing, firing directly from an engine nacelle. The third was on the aircraft's nose, alongside the pilot and co-pilot. Powerful 37mm turrets were used for the first time in the air. For the purpose of destroying enemy bomber formations, the Airacuda showed extreme promise, but it was not without its faults. Test pilots complained that it was slow, clunky, and difficult to maneuver against enemy attacks. The aircraft could not reach speeds above 277 miles per hour, failing to fulfill the role of an interceptor. As a fighter, its weight and design, which more resembled that of a bomber, made it vulnerable to flanking attacks from enemy fighters. It was poor in dogfighting conditions. These flaws, and the failed ambition of trying to succeed at 3 different combat roles, condemned the Airacuda to the prototype stage. It would not see combat in the upcoming war that threatened on the horizon. In 1935, Consolidated Aircraft Corporation decided to transfer its headquarters from Buffalo, New York, to San Diego, California. Disagreements among employees led to the creation of Bell Aircraft. Vice President Larry Bell, rejecting the relocation, decided to found his own company along with his assistant R. Whitman and chief engineer R. Wood. In the early 1930s, the Air Corps chief received several recommendations from renowned aviators urging him to develop a multi-seat military airplane. One-seaters had proven ineffective against bombers. American pursuit aircraft were subpar compared to the more advanced planes that England, Germany, and France possessed in the pre-war 1930s. Testing proved that unless the speeds of interceptors were greater than 40% compared to that of a bomber, the pursuit was futile. At that time, there were no U.S. escort or interceptor planes truly capable of outmatching both the bomber's speed and range. Nevertheless, many aviators in the Air Corps thought it was possible to develop aircraft that could catch up to a bomber's performance. On July 15, 1935, Air Corps Board Study No. 2 suggested the creation of an experimental multi-engine fighter plane. They requested, quote, an existing type for escort, but only if it did not interfere with the progress of other branches of aviation, until the need for an escort plane was demonstrated thoroughly. The Air Corps requirement also specified the need for the aircraft to fulfill various battlefield roles. They wanted an American plane that could match the German Messerschmitt Bf-110. This German aircraft had a multi-purpose role. It was a bomber-destroyer, bomber escort, and ground attack fighter. Creating a plane capable of these roles would not only be useful, but cheaper and faster to produce, too. Captain Claire Chenault, a strong advocate for pursuit aircraft, doubted that a multi-seat fighter could be successful against a bomber. Past experiences with pursuit aircraft, like the P-16 biplane and the P-30 monoplane, each equipped with an armed rear gunner, had ended in failure. He said, quote, since the interceptor must have a margin of speed over the bomber, we are confronted with the technical impossibility of building an airplane very similar in characteristics to a bomber, but considerably faster than a bomber. The Secretary of War urged the most serious consideration for the development of the multi-seat and multi-purpose aircraft. The General Staff was also profoundly interested in the project. In the event that they succeeded in creating a successful model, it would serve 2 of their purposes. First, the new plane would reduce the number of different Air Corps types, standardizing as few models as possible. And second, it would be cheaper to produce and replace. In November 1935, the Secretary of War approved the initial characteristics of the multipurpose aircraft. Months later, in 1936, a competition was held at Wright Field. The Lockheed Company submitted a design similar to the future P-38, and Bell presented the XFM-1. The X stood for experimental, F for fighter, M for multiplace. Spectators and judges were amazed by the futuristic design of Bell's aircraft. It looked original, unique, and powerful. The 37mm M4 cannons were mounted in a forward compartment in a cabin at each wing nacelle. These powerful cannons gave a hint of the damage the plane could inflict on enemy aircraft. The Air Corps was particularly impressed with Bell's new 37mm cannons, and Bell won the competition. When the contract was signed in 1937, it was agreed that 13 prototypes were going to be produced. It was determined that the XFM-1 would be the escort aircraft of the B-17 bombers. As the development of the Bell multipurpose heavy fighter began, the Air Corps was about to adopt the Boeing B-17 Flying Fortress as their default heavy bomber. Although the B-17 had its own defensive capabilities, an escort fighter was required for harassing the enemy aircraft that tried to target the heavy bombers. With the Bell Airacuda fulfilling the escort fighter's role, the B-17s could stay in formation with the rest of the bombing fleet, focusing solely on their designated objectives. When Bell started work on the first draft of the plane, they knew that if they wanted it to fill the roles of an escort, bomber, and pursuit aircraft, it needed to be fast, resilient, and versatile. For the aircraft to succeed at all of these roles, it needed to be able to fly at 300 miles per hour. As an interceptor or bomber, an operational range of 3,000 miles was ideal. Bell selected a typical twin-engine arrangement. The engines chosen were the Allison V1710-41s. The pair was going to be held outboard of the fuselage, in individual nacelles placed into each wing. The Airacuda had a pusher arrangement, in which the engine's propellers were placed aft of the wing's trailing edges. This unconventional design was made to place a small cockpit with a gunner in front of the nacelle. Its fuselage was composed of the bomb bay, the crew areas for the 5 members, and the systems that held the armament. A single vertical tail fin was affixed at the empennage. A front placement of the fuselage was an exciting and innovative aspect of the aircraft. Under the nose, a glazed cockpit was placed. Here, the pilot, navigator, and radio operator worked together with excellent visibility. The 2 remaining crew members, the gunners, had their work spaced in each engine nacelle's frontal area, where the lethal 37mm M4 cannon was placed, alongside an M1919 Browning machine gun that fired tracer rounds for improved aiming. Both gunners were able to access the glazed nacelle via a short tunnel that ran from the fuselage. The radio operator had one 50 caliber Browning M2 machine gun at each side of the fuselage for use against flanking attacks. The aircraft could also carry 20 by 30 pound drop bombs inside the bomb bay. It was expected that the Bell Airacuda would be so fast that it could overtake bombers, destroy them from a safe distance, and then rely upon its speed to evade hostile pursuit. They were so confident about this that no rear guns were placed in case the aircraft was attacked from behind. The first flight of the Airacuda was on September 1st, 1937. The first of the many flaws to plague the aircraft was its lack of speed. It could barely reach 277 miles per hour, lower than the expected speed of 300 miles per hour that the Air Corps required. With this flaw, the Bell aircraft would be unable to fulfill the role of an interceptor aircraft. These slow speeds were related to the overall weight of the Airacuda, which was 17,333 pounds. The additional weight of the bomb load was also useless. The 600-pound payload was not optimal for the fighter-bomber role. Another problem was the maneuverability of the aircraft. It proved challenging to stabilize the plane, making it incapable of dogfighting. Eric Schilling described his experience flying the Airacuda in the book Destiny, A Flying Tiger's Rendezvous with Fate. He said, quote, "Under power, it was unstable in pitch, but stable with power off. While flying straight and level, if a correction in pitch was required, a forward push on the control resulted in the airplane wanting to pitch over even more. Pitch control became a matter of continually jockeying the controls, however slightly, even when the aircraft was in proper trim. The same applied if pulling back on the control. It would tend to continue pitching up, requiring an immediate corrective response. The same happened in a turn with power off. The Bell became stable in pitch." Schilling also reported that another recurring problem for pilots was that the auxiliary power unit would all too frequently stall or quit, draining most of the current from the battery and powering off all the electrical systems of the aircraft. The M4 cannons, although highly effective at taking down targets, were incompatible with the tracer rounds of the Browning machine guns due to the difference in caliber. When firing, the M4 cannons also proved to be dangerous for the gunner. They tended to fill the cockpit with smoke, obstructing the view. A total of 13 prototypes were built to solve the ongoing issue of the Airacuda. None of them were able to satisfy the requirements of the Air Corps. When World War II broke out, the aircraft was still under modifications. It did not see combat. In 1942, the remaining Airacudas were scrapped. Although the Airacuda bomber-destroyer became a failed design for Bell Aircraft, the innovations the engineers tried to incorporate would pave the way for more promising ventures that awaited the company.